Welcome to tonight's Conversations with Great Minds with Paul Stamets. Paul is an inventor, researcher, entrepreneur, and has been a practicing mycologist for over 30 years. He has discovered and co-authored 4 new species of mushrooms and pioneered numerous techniques in the field of edible and medicinal mushroom cultivation. Paul was named a 2014 Invention Ambassador by the American Association for the Advancement of Science and received the highly acclaimed 2013 NAMA, North American Mycology Association, award for expanding the field of mycology for both amateurs and professionals. Paul's latest book, Mycelium Running: How Mushrooms Can Help Save the World, talks about the planetary healing powers of mycelium. Paul joins us now from San Francisco. Paul, welcome. Great to have you with us.
I'm honored to be here.
Thank you. You've got some props there with you. You have mushrooms with you. You want to tell us about them?
Well, sure. I brought 3 different mushrooms with me. These are polypore mushrooms. They're also called wood conchs. So they're more perennial. This is one of the rarest mushrooms in North America. It only grows in the old-growth forests. It's called agarikon. This mushroom has been used by humans for over 2,000 years. It used to be prevalent in Europe, but since they cut down the trees, they lost the habitat. This mushroom was the subject of research that we submitted to the BioShield biodefense program after 9/11, and was found to be a source of very, very potent antiviral compounds active against pox and flu viruses. This mushroom here is called turkey tail, and we had a successful $2.2 million NIH breast cancer clinical trial, and this mushroom was found to be very potent in upregulating the immune system, and in combination with chemotherapy enhance the positive effects of chemotherapy. And then one of my favorite mushrooms is this one called amadou, and my hat is made from amadou. And this mushroom is called the tinder conch. It allowed for the portability of fire. And our ancestors, not too long ago, you didn't have Bic lighters and matches, and this would help keep the clan alive because the firekeeper of the tribe had a very important role to carry fire. And there's no doubt that we all came from Africa, and we went north. We found something new called winter, and this mushroom allowed for the portability of fire and helped keep our ancestors alive.
Remarkable. So, Paul, let me start at the beginning. What got you into mycology, into the study of the study of mushrooms, the science of mushrooms?
Well, I was always attracted to that which was forbidden, and I was always curious at people's strong reactions about mushrooms, and it speaks to the fact that, you know, most mushrooms are fleshy mushrooms. They're very temporary. They're in the visual viewscape for a few days, 4 or 5 days, and then they disappear. And mushrooms that can kill you, that can feed you, that can cure you, that can get you high, something that's so potent like that, but we have such a limited experience with them compared to animals and plants. We have a long exposure. We have lots of time to learn their properties. And these other mushrooms come and disappear very, very quickly. So there was an area of science that was understudied, and yet most people may not know that 40% of the biomass of soils is fungal, and 70% of soils, approximately the microbes in soils, are also fungal. So these are the very foundation of the food web, and these mycelial networks are fine, cobwebby-like membranes that permeate all landscapes, and these are called the fruit bodies. Like an apple is to an apple tree, this is the reproductive structure. So they surface and they produce these mushrooms, and spores come and fly around, and then they quickly disappear. These, on the other hand, are more perennial, and so our ancestors have had a longer history of experience with them, and so we know a lot more about them.
What is mycelium?
Mycelium is the fine cobwebby substance, and anyone listening can go out to find a piece of stick on the ground or a piece of wood and tip it over. You'll see mycelium. It's a network of fine cells, and these networks can be incredibly large. The largest organism in the world known so far is a mycelial mat in eastern Oregon of a honey mushroom, 2,200 acres in size. And yet they're only 1 cell wall thick. On the other side of that cell wall are hundreds of millions of other microbes trying to consume it. And yet these mycelial networks can be vast, and they connect the forests, and they're really a form of Earth's natural internet, and they bidirectionally move nutrients to support plant communities.
Do they, in addition to nutrients, do they communicate? I've read about trees communicating with each other by by releasing the equivalent of pheromones or hormones or chemicals that are like screams, essentially?
Excellent question. And there's been a number of research projects, and it gives me somewhat, I'm a little sad about this, that we're just discovering this now. But through the mycorrhizal fungi that join the root zones, if a plant is being attacked by an insect or there's other type of predation, then via the mycelium, it alerts the adjacent plants that there's a predator on the horizon. So these are essential communication networks as well as nutritional networks.
Wow. So it very much is like the internet, or even better, because the internet doesn't nourish us unless we, I guess, order a pizza online. What do mushrooms and their structure demonstrate about the interconnectedness of nature, Paul?
Well, we live in a very fragile ecosystem. We are here today because of very smart choices on the evolutionary path. I'm Paul Stamets, but I'm 10 trillion bacterial cells to 1 trillion, approximately, human cells. Now, the bacterial cells, the mass is only 1 or 2 pounds of bacteria in us, relative to my weight. But it speaks to the fact that we live in communities of microbes, as does the soil, as do all plants. And so guilds of microbes have allied with each other, cooperating, saying, if you help me, I will help you. And so these large communities have established themselves in the ecosystems. And so we are a community. Our plants are based on communities. And as we lose biodiversity, we are facing some very big challenges. The food webs are being eroded underneath our feet, and we have very little knowledge. One of the examples I like to give, there was an asteroid that came by the Earth yesterday, 60 feet in diameter, not seen until just the last moment. Well, if there's an asteroid impact coming at us in 12 months, all the nations of the world would gather together to try to divert that asteroid. Well, we do have a proverbial asteroid coming at us very quickly. We're entered into 6X, the sixth greatest extinction event known in the history of life on this planet. We have approximately 8.3 million species of organisms on this planet. We're losing about 30,000 species per year. Well, in 100 years, that's more than a third of the biodiversity of this ecosystem that's given us life. As we dismantle the ecosystem underneath our feet, we are jeopardizing not only all sorts of other organisms, but ourselves. And this is something that I think that people really need to focus on the biology of the soils, which we have very preliminary knowledge of. We have all the sexy animals like giraffes and elephants and tigers and lions and bears. Of course, we know a lot about those, but the microbes we know very, very little about.
You say that there is a mycological solution for this sixth extinction. What is that?
Well, we suffer from overpopulation. I think everybody agrees with that. With overpopulation, we have habitats being destroyed and we lose biodiversity. We have pollution and we have climate change. These are all stressors on the ecosystem. And as we lose organic debris in our humus and our soils, we're dismantling the food webs that give us life. The fungi break down plant material and render more nutrients to other adjacent plants. And the decomposition cycles spin off all sorts of nutrient cycles that give rise to myriad populations of organisms that help the biodiversity. The more biodiversity is biosecurity. The more biodiverse an ecosystem is, the better it is able to respond to catastrophia, to human impacts, to pollution impacts. And as we erode the soil system, we only have 10% of the wood debris in the forest now than we did just a few hundred years ago. So 90% of that soil has been denatured, and the ecosystem now is being stressed out. And the role of nature is that when an organism exceeds the carrying capacity of its ecosystem, then diseases spread. And so now we have entered into a period of viral storms. We have massive amounts of pollution. We have water quality issues. We have water wars that are developing. And this is because the mycelium holds water in the soil. And most people don't realize this, but when this wood is decomposed, a major byproduct of wood decomposing is water. And so the mycelium nourishes and gives water to the ecosystem to the benefit of the myriad other organisms. And it's an all hands on deck moment. We really need to step to the forefront and be able to develop biodiverse agriculture, not monoculture. We need to reinvest in the biodiversity of the ecosystem because ultimately that's the safest route for us.
How do we do that?
Well, we do that by putting wood chips on the ground, by gardening, by planting diverse species in our landscapes, by trying to avoid going into monoculture agricultural systems, by engaging permacultural models. And I'd like to recommend to everybody that they join a mycological society. The mother society is called the North American Mycological Association. It's a nonprofit. It's namyco.org, namyco.org. You join one of the North American Mycological Association, and they can help steer you to all sorts of other experts. And it's tons of fun. You go out, it's like an Easter egg hunt for adults and for children. And indeed, many elderly adults have told me their favorite memories are being with their family when they were kids hunting mushrooms. You're away from the phone, you're away from the business, you have direct communication with your parents, and you have that eureka moment, which is an endorphin rush. And when you find something in the woods that's just, so rare or so wonderful or so delicious, you're rewarded. And it's really enticing. It's a wonderful lifestyle. I highly recommend it to everybody.
Wow. You're the inventor of the Life Box. What is that?
Life Box was my reinvention of the cardboard box to try to, because we all have too many cardboard boxes and we ship them, the delivery system's already been paid for. So I impregnated sheets of cardboard with beneficial fungi and seeds. And so as every box that could be shipped, ostensibly could be an ecological footprint to reestablish a forest. And so my idea was to reforest, the world through life boxes, since there is no additional weight. And then I'll teach kids about biodiversity. They can grow the trees, and then when they're grandparents, they can walk into a forest that was planted by a life box when they were a kid, and they can teach their children generationally about the importance of reforestation. Wow.
Is this a product that's out there right now?
The product is out there right now, but it's been a labor of love, and it's something that has been limping along, and I've got lots of excited people about it, but the bottom line is that the purchasers of in these large companies, they want to compete against a plain brown cardboard box.
Right. Yeah, that's a tough one. We'll pick up this conversation right after this break. More of tonight's Conversations with Great Minds with Paul Stamets after this break. Welcome back to tonight's Conversations with Great Minds with Paul Stamets. Paul has been a practicing mycologist for over 30 years. He's discovered 4 new species of mushrooms and pioneered numerous techniques in the field of edible and medicinal mushroom cultivation. Paul's latest book, Mycelium Running, How Mushrooms Can Help Save the World, talks about the planetary healing powers of mycelium. Let's get back to it. Paul, you've talked about universal truths in nature. What are some of these truths?
Well, the ability to adapt to change is the wedge of evolution, and it's really important that you're able to adapt very quickly and intelligently. Network-based organisms, which is what mycelium is, has the ability to constantly change according to circumstances. When the mycelium grows out, in the width of this table here, there can literally be millions of end branchings that are constantly forking. And the nuclei stream to the tips. And if there's a new toxin, a new food source, a new insect, a new piece of wood, a new potential food source, if there's a reassortment of nuclei, a new enzyme can be produced and digest that potential food source. If that happens, then the network is, information flows backwards into the mother mycelium, and so these are learning membranes. They're sentient, they're aware, they're highly adaptive. So the universal truths that I see in nature is the organization of the universe, dark matter and dark energy, mycelium, neurons, our brain are all based on these vast networks that have multiple pathways. Should one of them get interrupted, there's an alternative pathway, as opposed to a linear system. If there's an interruption, then the organism could be killed or stopped. So the adaptiveness of network design is something that I think we'll find pervasive throughout the universe. I believe that, this is my own personal belief, I grew up in a highly religious environment, but my personal belief is matter begets life, Life is first single organisms become strings then fork, chains are produced, membranes are produced, and this is the way of life, I think, throughout the cosmos. We'll find network-based organisms elsewhere in the universe. This is not an accident. I think this is just the way of life.
I think you're absolutely right. How are humans, I mean, most people know that we have a relationship with bacteria, if nothing other than seeing ads on TV for probiotics. But going beyond bacteria to fungi, or am I pronouncing that correctly?
There's four correct pronunciations. All of them are correct.
Okay,
so.
Great. Thank you. How are humans interrelated with mushrooms?
Well, excellent question. Well, we diverged from fungi about 650 million years ago. In fact, a group of scientists, 23 of them, published an article about 3 years ago erecting a new super kingdom called a Pleistocanta. A Pleistocanta joins fungi and animals together. We have a more common ancestry with fungi than we do with any other kingdom. In fact, it can be said that our ancestors were proto-fungal. We evolved from the very, very same ancestors that our modern fungi have evolved from. And we exhale carbon dioxide, so do fungi. We inhale oxygen, so do fungi. Our best antibiotics against bacteria come from fungi. But we have very few good antifungal antibiotics because we're so closely related as eukaryotic organisms to our fungal ancestors. So that's some examples, but it's very interesting. And as we selected out the microbiome of bacteria that makes us healthy, fungal networks have done the same in nature. So they predispose populations of bacteria and other organisms that help the plant communities to give rise to the plants in the forest to create the debris fields that feed the mycelium. These are deterministic in their organization, and they select communities that benefit their own progeny. So this is a really something that's so important for us to understand. Is biodiversity is biosecurity. And we are here today because of the biodiversity that we have. And when you take antibiotics, you not only kill the bacterium or the infectious organism that you're targeting, but you also massively disrupt the microflora in your gut. And so this is why the rampant use of antibiotics is causing all sorts of downstream medical implications that are very, very serious.
You mentioned eukaryotic. What does that mean?
Eukaryotic organisms are what we are. We have a nucleus, and that defines what a eukaryote is that our DNA is inside of a nucleus and the mitochondria.
Yeah, okay. Yeah, essentially two nuclei. You quote from you, I believe habitats and inhabitants share immune systems, and mycelium is the cellular bridge that governs the two. Can you explain that?
Well, this is what I'm saying is that the habitats do have immune systems, and the healthy habitats speak to their healthy immunity. When we insult them with a pollutant or a toxin, then the mycelium has to react and decompose those toxins, or else the population that it hosts is in jeopardy, and its own progeny is also in jeopardy. So mycelium is a cellular bridge that connects all landscapes. All plants are part fungi. Basically 90% of all plants are part fungi. This was not known until just recently, when biologists would constantly see these fungi under the microscope and wondering, well, how is this possible? And now we know that the endophytic fungi that grow inside of trees, inside of plants, inside of grasses, give a host defensive resistance against pathogens and parasites. And so again, this speaks to these very complex guilds and communities of cooperators that cooperate together in order to forestall pathogens from sweeping into the landscape and changing the very nature of that landscape. You know, we're the biggest walking catastrophe on this planet, and we inflict damage. The problem that we face today is the xenobiotic, the artificial toxins that are being created by humans. Never in the history of evolution has there been any experience of this. There are tens of thousands of new pollutants and toxins. The ecosystem is under assault. Whether its immune system can be able to mitigate all these different pollutants at once is a very, very challenging question. And I'm afraid that the ecosystems are not going to be able to react fast enough unless we start to mitigate the outflow of toxins that are having all this collateral damage.
Biomimicry is it's kind of an in vogue word. Explain what it means and how it applies to our relationship with mushrooms.
Well, biomimicry speaks to the fact that one of the best examples is the invention of Velcro, and the invention of Velcro and lots of other things we know about today are modeled after nature. And the biomimicry is the scientists now and the industry looking at how natural systems have evolved to take care of many of these problems that we're facing. I came up with a term, not a big giant leap in logic here, but called mycomimicry, and the idea of creating network systems based on our knowledge of how mycelium works and setting up the biosphere and these microbial populations is something that I think is also very, very useful for us. This is where a problem that we have science is, and the computer sciences and in astrophysics. We know extremely little about soil biology. Good luck going to Mars. You're going to have to try to grow. You know how to create soil? Almost no scientists know how to do that unless they have nature as an inoculum that we can transfer a native soil and create soil. But creating a soil from a test tube is not possible because the organisms are what we call immunologically naive. That is the baby in the bubble syndrome. If you're not, this is why it's encouraged that kids play in dirt. Their immune system needs to have experiences of these microbes so it can upregulate the antibodies and become immunologically educated. This is the same as is true with soil systems. We can't create soil on other planets with the biodiversity that we have seen here on this planet to give us life. And so I think rather than going into the stars, we better stay home and focus on this beautiful planet that we have right now because it is a jewel. We can use it as a model, but if we lose the ecosystems, we've lost the model for being able to populate other planets in the universe.
What are the practical steps that we could be taking right now to use mushrooms to address global warming?
Well, that's a really good question. The mycelium, as it builds the humus, I gave a talk at TED, and Al Gore came up to me afterwards and said, "You taught me something I didn't know." I thought, well, I was going to respond to that in a sarcastic way, but the soil, as it builds up the humus in the soil, the carbon is being sequestered into the soil biosphere. It's not being liberated into the atmosphere. The mycelium produces cold carbon dioxide, but the mycelium is about 85% carbohydrates. It's extremely heavy in carbon. And then as the soil debris and the wood debris builds up in the ecosystem, the carbon bank is being built as well. So you're not liberating this into the atmosphere, you're building a carbon bank within the soil. So the practical things that people can do is don't throw away your wood chips and your grass clippings, and then you bring in fertilizer. You need to decompose that material in situ in your landscape and building up the biosphere in your ecosystem. The presence of mushrooms in your yard is a happy sign, with a few exceptions, but it really means that your ecosystem is thriving, the decomposition cycles are moving, and everybody should come to terms with fungi one way or the other because they're going to get you in the end.
Yeah. The chicken and egg question here. Our soil seems to be dying, particularly here in the United States, and most people point the finger at factory farming, monoculture, industrial agricultural practices. To remediate that, should we be, which will bring mycelium back into the soil, as you point out, and make the soil more resilient and more moist and more carbon dense, do we need to inoculate the soil with mycelium, or do we need to just start doing appropriate agriculture and then the mycelium will follow?
Great question. We can be more purposeful now, and we need to be purposeful because we don't have time just to have random access of natural fungi leaping to the forefront when we have an immediate issue. We received an EPA grant, phase 1, for mycofiltration, filtering gray water of E. coli, and we found a mushroom called the garden giant that's exceptionally good at capturing E. coli, cleaning water, breaking down the wood chips, and is plant friendly. And also produces these compounds that consume nematodes. So it's very good for root crops, etc. But that's a real good example of a species. We have about 700 species in our culture library. We grow enormous amounts of mycelium, 20,000 kilos of mycelium per week. And so we have about 7 different projects now, from Lake Erie to Portland to other regions, where we're cleaning up street waste. And water does not discriminate between E. coli and oil. And so you have a convergence of toxins, and we create these sheet mulch beds with the mycelium of the garden giant, for instance. And as it infiltrates through the mycelium gobbles up the hydrocarbons and remanufactures them into fungal carbohydrates, into sugars. And then the extracellular sweat droplets coming from the mycelium, a la the invention of penicillin, those break down E. coli, and then the fungi consume the E. coli.
So this is brilliant. I'm sorry, we just ran out of time. We hit the end of the show.
No worries.
That was great. Paul Stamets, thanks so much for being with us.